Database versus object storage. S3 for large blob storage. Hello everyone! Today I'd like to walk through how to store large files in system design. This is a very common problem: images, videos, documents, user uploads. But the key question is, should we store them in a database or in object storage like S3? When evaluating database versus object storage, I usually break it down into 5 dimensions. First, data size and storage cost. Second, access pattern and throughput. Third, transaction and consistency requirements. Fourth, scalability and operational complexity. And fifth, large file upload strategy. Let's go through them one by one. Data size and storage cost. Let's start with storing blobs in a database. This approach is simple. Metadata and file content live in the same system. It works well for small files and tightly coupled transactional data. But databases are not designed for large binary objects. Large files increase storage cost, slow down backups, and make replication expensive. So the key idea is databases are good for small, tightly coupled data, not large blobs. Now let's look at object storage like S3. These systems are designed specifically for large-scale binary data. They provide extremely low storage cost, massive scalability, and high durability. But they require a separate metadata system and introduce an extra network hop. So the key idea is object storage is optimized for scale and cost efficiency. Access pattern and throughput databases are optimized for structured queries, not for delivering large files. Large blob reads increase disk I/O and degrade query performance. Object storage uses HTTP-based access and integrates naturally with CDNs. We can even generate pre-signed URLs so clients download files directly from storage. So the key idea is object storage enables direct, scalable file delivery. Transaction and consistency databases provide strong ACID guarantees. This allows metadata and file content to be written atomically. With object storage, we usually use a 2-step process. First, upload file to storage, then save metadata in database. This introduces complexity because partial failures must be handled. So the key idea is databases simplify consistency, while object storage requires coordination, scalability, and architecture. As systems grow, database blob storage becomes problematic. Larger backups, slower replication, and higher cost. The common architecture is client-to-application to database for metadata and object storage for files. So the key idea is separating metadata and blob storage enables independent scaling. Large file upload strategy. Now let's talk about large file uploads. Uploading a large file in a single request is unreliable and inefficient. For example, a 500 millibler upload fails at 90% and you have to restart from zero. The solution is chunked or multipart upload. We split the file into smaller chunks and upload them independently. Typical flow: client requests upload session, server returns upload ID and pre-signed URLs. Client uploads chunks directly to S3, then completes upload. This provides retry per chunk, parallel upload, better reliability, and no load on application servers. So the key idea is large-scale systems offload file uploads directly to object storage. Summary. To summarize, databases are good for small files and transactional consistency. Object storage is better for large files, scalability, and cost efficiency. In practice, we almost always use a hybrid approach. Closing insight to conclude. The real architectural goal is not choosing one over the other. It is decoupling structured data from large binary objects. Databases manage metadata and transactions. Object storage handles scalable file storage and delivery. That is how modern systems scale. Thank you.